All right. So, hello and welcome everyone. So, we are live right now. I hope I'm audible to all of you. Am I audible to all of you? Please let me know in the live chat. Okay, fine. So, yes. So, we are live right now and welcome back to this amazing platform of Tutee Learning. And today, we will continue our discussion on planes, right? So, as of the last lecture, now, if you haven't watched the last lecture, it is very important. Please go back and check out the playlist. We have already discussed a lot on 3D geometry, right? So we have finished with the straight lines in space, and then we started with the discussion on planes, right? So in the last lecture, which I took previously yesterday, we discussed about certain important things regarding a point and a plane. Also, we discussed about how to calculate the angle between the plane. Also, how to calculate the perpendicular distance between two parallel planes or a perpendicular distance of a point and a plane. So that's all we have seen so far in our previous discussion, right? So in today's class, we are going to discuss about another very important concepts regarding the line and the plane. So we will begin to discuss about the concepts of lines and planes. Okay. So today we'll discuss and start to discuss about lines and plane, right? So first and foremost thing we'll try to look into is we'll first of all look into the equation of the plane through a given line. So if I need to find out the equation of a plane through any given line, okay, so if we need to find out the equation of the plane through a given line, how do we do that, right? So let us try to understand that particular thing. Now before I jump directly into the formulation of this problem, let us try to understand what does this physically means. Okay, so if we try to understand is that, so it is asking you to formulate the equation of a plane which passes through a given line. Let us say like this. So you have a plane over here, and the line, let us say this is my line L1, and this is my equation of plane P, or let us say this is line L, right? So this particular line lies entirely on the plane, right? So I can consider this question as the question of that when the line lies completely on the plane. So how do we solve these kinds of problem, right? So let us try to generalize this problem. So first of all, if I try to write the line equation is given to us, right? So I written over here that it is the given line, right? So let me write the equation of line as x minus x1 upon L is equals to y minus y1 upon m is equals to z minus z1 upon n, right? So let me first of all write the following equation of line. Okay, so let me first write this following equation of the line which is given to us. Now what I can understand from this following concept is that I can do a very interesting understanding that since I know that what is a fixed point that is lying on the line. So from this I can say that x1, y1 and z1 is a fixed point which is lying on the line as well as it's lying on the plane. So I can consider this as my fixed point on the plane as well, right? Now also I know the direction ratio vector of the line, which is a vector lying in the plane. So this particular vector can be given as Li cap plus Mj cap plus Nk cap, right? So this particular line is given as something like this. Okay, so this is the vector which is lying on the plane. So this is a point on the plane, and this is the line which is lying, or this is a vector which is lying on the plane. So we have this formulation, right? So we will see that if I have this formulation from here, if I take up any random point, let us say x comma y comma z, which is lying on the plane, so I can use this x1, y1, z1 to create another vector. So this is my another vector. Let us say that the point on the plane and the line is A, and let us take a random point R. So then this is my AR vector, and I already have another line vector. So the cross product of L would give me the perpendicular vector that is perpendicular to this plane, right? So in order to obtain the perpendicular vector, that can be easily obtained by doing a cross product of this line vector or the vector of directed along the line and the AR vector, right? So if I do that formulation and I try to write the direction ratios of the of the final normal of the plane, we'll try to see that the equation of the plane will be modified to equation of the plane will be modified to now the equation of the plane will now be modified to, we'll have ax minus x1 plus b times of y minus y1 plus c times of z minus z1 is equals to 0. So this will be the final formulation of the equation of the plane. Okay, so where a, b and c is given by, so a b, c are the direction ratios of the normal vector, right? So I'm writing as dr in short form of the normal vector to the plane, right? So therefore, and this can be also given by the dot product result as a dot l vector. So this particular vector, that is n vector dot l vector, should be equal to 0 because they are perpendicular to each other, right? So with this you will obtain another relation, that is al plus m times of b plus n times of c should be equals to 0. So this will be the result for, or the equation combining a, b and c. So if we have the equation of the line given something of this form, then I can write the equation of the plane to be of this particular form. Is this part clear to all of you? Is this part clear? Hi, Sudha Reddy, right? All right. So I hope this is clear. Please do let me know if you have any questions. Okay, I'm open to any types of question if you're having any. So we'll try to see some questions in today's class as well, right? But before that, let us try to understand the theory aspects of the concepts of a line and a plane. Okay, now there might be a one more variation to this problem. There might be another variation to the problem, as so instead of giving you any particular line that is lying on the plane, if I say you that there is a plane, right? Now instead of giving you one line, let us say there are two lines which are lying on the plane. Let us say this is L1 and let us say this is L2. Now this question is much simpler than the previous one. So this question we know a two fixed point that is lying on the plane and the line. So the normal vector to the plane can be easily obtained by doing the cross product of these two known vectors. The normal vector would be obtained by taking a cross product of these two known vectors, that is L1 and L2 are the known vectors. So I can easily obtain my normal vector, right? So if I have the question such that instead of giving you one line, if I say you that there are two lines which is lying on the plane, then I can easily obtain the normal vector. And once I obtain the normal vector, I can consider any fixed point of line L1 or L2 to be a fixed point on the plane. And then I can formulate the equation of the line or the equation of the plane, right? That is my main motto. Right? So this, so it will be A times, so I can write this something as ax plus by plus cz is equal to some d. So that I can also write in terms of a determinant relation saying that x minus x1, y minus y1 and z minus z1, and then we will have L1, M1, N1. So where x1, y1, z1 is any a fixed point on either of this line L1 and L2, right? And this is will be, and the third row will be L2, M2 and N2. I hope this is clear to all of you. Oh, sorry, it should be M1, right? Yes. So this part should be equal to 0, right? So if you do this particular relation, then you will be able to get the equation of the plane. Now, if you recall from the discussion on the coplanarity concept, the coplanarity concept of lines on a plane, we will see that this is the shortest distance to be equal to 0, right? So if you have two lines on the coplanar lines, right? So if the two lines are coplanar, the shortest distance is equals to 0, because there might be a chance that it will intersect each other unless and until they are a parallel lines, right? Also, if there are parallel lines, then this question becomes reduced to the question of this previous case when you have a line and a plane, right? Only one line and a plane, right? So I hope this formulation is clear to all of you. So this is how we'll formulate the equation of the plane. Okay, is this part clear? Is this part clear? So we'll try to look into some problems, okay, shortly, or let us look into some problems before we proceed for another important topic, right? All right. So here is your question. So you can take this particular problem. This was a problem from the previous year IIT problems. You can see the date. It is too old problem, right? But still a basic question or a fundamental problem, right? So please try to look into the problem. Please try to solve the problem. First of all, go through the problem and try to understand what is basically meant by the problem, right? So please try to read through the problem. Try to read through the problem and try to understand what is basically being asked in this problem. Okay. All right. So please let me know the right answer. Which option is going to be the correct one? This is going to be a very interesting problem, right? And yet a fundamental problems. All right. So I'm waiting for your answers. Any answers? All right. So I hope you have tried option C. Option C is the correct answer. You are saying, right? Yes, correct. Correct, Shaurya. Option C is going to be the correct answer. Very good. Wonderful. So I hope you're all able to solve it, right? It's a very fundamental problem. So if you try to read through the problem, first of all, the question says that you have a non-zero A vector which is parallel to the line of intersection of the plane determined by the vectors and the plane determined by another set of vectors, right? So if you try to understand the problem, it is said that A vector is parallel to the line of intersection. Now, how to find out the line of intersection? There's a very, very important concept. So it is said that there are two planes, and instead of giving you the equation of plane, they are saying you which are determined by the following vectors. That means that is two lines lying on the plane. And so this particular vector, which is formed by the intersection of the two planes, is given as a vector to me, right? So the plane, let us say P1, and let us say this is P2. The plane is having the vector I cap, and this is my I plus j cap, right? And this plane P2 is having the vector I cap minus j cap, and this is having my vector I cap plus k cap, right? So these are the following formulation. So how to find out the direction of a vector? To understand this, you have to have a bit of an understanding of the three-dimensional visualization. Okay, so please try to visualize this thing. So if I say that this is my normal vector to the plane P2, let us say N2, and this is my normal vector to the plane P1, and let us say N1. Now, if you look into this carefully, if I try to find out the cross product of N1 and N2, I will find the vector will be directed along the direction of a vector, right? So the easy way to find out this particular vector is to just take a cross product of the two normal vectors. Okay, so this a vector can be easily obtained but just by doing the cross of the normal vectors. Now the problem over here is to how you are going to formulate the how are you going to formulate the normal vector, right? Or how will you find out the equation of the plane? Now to find out the equation of the plane, it is very simple. I have two vectors, right? Now I can take the cross product of this I cap and I cap plus j cap to find out the n1 vector, and similarly I can take the cross of I minus y I cap minus j cap cross with I cap plus k cap to find the n2 vector. So let us do that operation. So n1 would be I cap cross I cap plus j cap, and that would come out to be k cap, and n2 vector would be just I cap minus j cap cross with I cap plus k cap. So if you do that, so if you try to do this particular result, it is going to come out as minus j cap, and so minus j cross I is going to be uh, minus of k cap, and j cap cross minus j cross k, or j cross k is going to be I, so minus of I cap. I hope you are able to get this following normal vector. Right, so I got the vector n1 and n2, right? So I got the vector n1 and n2. Now the only thing I have to do is that I have to perform again a cross product to find out the a vector. So this can be again simply done as 0, 0, 1, minus 1, minus 1, and minus 1. So if I evaluate this result, my a vector is going to be equals to minus I cap and minus of minus j cap, so that's going to be plus k cap, right? So I will obtain my a vector to something like this, minus I cap plus j cap. So once I have this, I have to find out the angle between the vector a and another vector I minus 2j plus 2k. So that will be obtained by doing the dot product. So the cosine of theta would be obtained as a dot that particular vector, let me call it as b vector, and then divide by the modulus of it, right? Yes, PG bolt, yes. Okay, so then if I do that, the result is going to come out as 1 upon root 2. Okay, so the result, if you do it, it is going to come out as 1 upon root 2. So, or maybe plus minus 1 upon root 2. Okay, so with this, you will see that the angle can be pi by 4 or it can be 3 pi by 4. Okay, is this part clear? TV gaming, please use your mind. Okay, I think you don't have any brain. If you are watching any particular content, it must be given. The name is already given, right? So why are you asking about the name? Please check it. I think you can read English, right? I'm from IIT Kharagpur. Should I do calculus or matrices? See, first of all, what is your current level? TV gaming, what is your current level? Are you good with the concept of calculus? Or have you basically studied calculus anytime previously? So the answer to your question, no, like future preparation. Okay, for future preparation, I would say that you should prefer go or start with functions, okay? Because or calculus part, right? Because once you understand the basics of functions, calculus things, maybe some questions in matrix and determinant is going to be there that is going to ask you about calculus in the matrix and determinant thing, okay? So the better thing is basically to be starting with the calculus part. Okay, is it clear? TV gaming, is this part clear to all of you? PG Bolt, if you want to know more about me, please check out the description box. Okay, everything is clearly mentioned in the description box. Please check out the description box to know whatever your queries are. Okay, is this part clear? Okay, so already people have answered to this question. So answers option C is going to be the correct answer, right? So this is how simple the question was, right? Only thing that was difficult in this problem was to visualize that by taking the cross product of n1 and n2 vector, we can obtain the vector which is directed along the line of intersection. Okay, so there is a very important question, a very fundamental problem. Okay, so please take a note of this problem. Okay. Sir, you explained the Newton-Leibniz formula. Yes, I have already explained the Newton-Leibniz formula. Okay, please check back my lecture series on limits. Okay, or definite integral. Okay, in definite integrals I have explained it, and also in limits also I have explained it. Okay, so please check those both lectures. Okay, so in definite integral I have explained Newton-Leibniz rule, and I have solved some questions also. Right. Also in the chapter of limit also I have explained the Newton-Leibniz rule too. Okay, so please watch those lectures so that you can get an entire understanding of whatever we have done, right? Or whatever thing is relevant for your IIT JEE syllabus. Okay, is this fine? All right, so let's now move to another important concept, that is the concept of intersection of a line with a plane. So again, let us say that we know what is my plane over here, and let us say that I give a line. This is my plane, and I know any particular line passing through it, right? So I know this particular line, and the question is asking you to find out that particular point of intersection of this line and the plane. So I'm calling that particular point as alpha comma beta comma gamma. Please explain Euler-Toroid function. Arav, what do you mean by Euler-Toroid function? I can't get your question. Sir, which chapters are important from 11th portion? From 11, the chapters that are important is going to be coordinate geometry. Entire coordinate geometry is very, very important. Okay, starting from straight lines, circles, hyperbola, parabola, ellipses. These are going to be very, very important. Trigonometry is going to be very fundamental and basic chapter that you must study. Okay, and apart from that, binomial theorem, permutation combination, complex numbers. Okay, and also quadratic equation and sequential series. Okay, these 5 chapters from algebra, 5 chapters from coordinate geometry is going to be the most relevant and important chapters from 11th portion. Okay, but if you look at the weightage is always like calculus has the highest weightage. Okay, so for class 12 portion of calculus, and then matrix indeterminate, vectors 3D geometry, probability, and then we have those chapters of calculus, and also with that coordinate geometry is also very important. Okay, so if you are planning to prepare in an easy manner, I would definitely suggest you start with easy chapters like vectors and 3D geometry, matrix indeterminate. Only do the coordinate geometry part, and I think you will be able to score at least a decent score in your JEE Mains examination. Okay, but if you are targeting for JEE Advanced, you have to have a good amount of preparation in all the basic concepts. Okay, your basic has to be very clear. All right, let's come back. So we were looking at this intersection point, right? So we are trying to find out the intersection, right? Intersection of a line with a plane. So we are trying to look at the intersection of a line and a plane. Intersection of a line and a plane. Okay, so let us try to understand how do we find out the intersection of a line and a plane. Okay, so In order to find out the intersection of line or plane, the concept is very simple. Let us say we know the equation of the line given something like this. Okay, let us say this is the equation of the line that is already given to us, and we will already know the equation of the plane. We will know the equation of the plane. So let us say the equation of the plane is given as ax plus by plus cz plus d is equal to 0. So this is my equation of the plane. This is the equation of the line, so I'm representing by L, and the plane I'm representing by P. Okay, so this is the equation of the line and the plane. Now, in order to find out the point of intersection, this point of intersection would lie both on the line as well as the plane. So let us assume any point on the line by assuming some constant mu. So then any point on the line can be given as x1 plus L times of mu, comma y1 plus mu times m, comma z1 plus mu times n. Now this particular point will also lie on the plane, so I will just need to satisfy this particular point to the equation of the plane as well. So it will obtain as a times of x1 plus L times of mu plus b times of y1 plus mu times m plus c times of z1 plus mu times c plus d should be equals to 0. So if I solve for this equation, I will obtain the value of mu. Now you know the rest, right? So once you get the value of mu, you get the value of a. So from here, you will get the value of mu, and that can be substituted over here to get that particular point of intersection. Is this part clear? Now the main understanding is not to find out the intersection point. However, there is a question like to find out the intersection of the line and the plane. However, I want to know that what is the angle that this line is making with the plane, right? So if I'm interested to know that what is the angle that this line is making with the plane, to solve that particular problem, what I can do is that so if you try to understand what I'm asking is that, so there is a plane like this and there was a line like this, right? So this line is, let us say this vector is L vector, and we have the plane. Now for the plane, we have the vector which is perpendicular to the plane, right? So if I represent that particular vector over here, it is something like this, right? So, and it is called this point of intersection as point A. Now, sir, can you tell me some reference book for mathematics? There are a lot of reference book for mathematics. I will come to it, but let us first of all understand this concept. Okay, so in order to find out the angle between the plane and the line, which is this particular angle, so that angle between the plane and the line is this particular angle, right? However, I know the vectors of the line as L vector and the vector of the plane as the n vector, right? So by using these two vectors, what I can do is that I can come out with this particular angle. Now this particular angle is nothing but the angle that is pi by 2 minus theta, because we know that this plane and the perpendicular is basically having a 90-degree angle. So if this angle is theta, this angle should be pi by 2 minus of theta. So that I am trying to represent over here, right? So if we use this concept, so then my cosine of pi by 2 minus theta would be given as n vector dot L vector divided by n vector mod and L vector mod. So just by doing out this operation, I can find out my cosine of pi by 2 minus theta. So pi by 2 minus theta is the angle over here. So therefore, from here I can use a trigonometry, that is sine theta should be now equals to n vector dot L vector divided by mod of n and mod of L. So this is going to be the result for the vector. So please note that in general case you will always have a cosine inverse, right? However, in case of line and a plane, you will have the result as sine inverse of dot of this and divided by the magnitude result of this. Is this part clear to all of you? So this is how we can find out this particular angle. Okay, this is how we can find out the angle between the vector. Okay, so this is how we find out that required angle between the line and the plane. Is this part clear? Is this part clear? Is this part clear to all of you? Okay, so let us come back to the question of uh, TV gaming. So he asked me basically, I don't know is he or she. So basically that guy, that person asked me for, sir, can you tell me some reference book for mathematics? Okay, so I'm coming to this question answer. There are a lot of reference books. However, please try to be relevant as much as possible to your syllabus. Okay, so uh, so the reference book that I would suggest is that is should be like, first of all you should be completing your NCRT. Okay, the NCRT mathematics textbook for class 11th and 12th. Along with NCRT, please solve the NCRT exemplar. Now these two has to be done simultaneously. Okay, there are two benefits of it. So if you solve the NCRT and the NCRT exemplar, you are going to do very good in the board examination. So at least your board examination score you don't need to worry about, right? So you can easily target 100 upon 100 in the board examination just from these two textbooks. Apart from this, if you think that okay, now if you are preparing for competitive examination like JEE examination, now I would suggest you can pick up any of the relevant series that is available in the market, like Aryan series or the Singer series. Both of them are very good. Okay, so you can refer to any one of them. Okay, that's all the textbook that you need to do, right? Please don't jump to multiple textbook. Please don't jump to multiple coaching modules or any other things. Okay, try to be as relevant to the syllabus as you can, right? Don't try to solve lot of books, because that will actually demotivate you if you are not able to solve some questions. That's why please try with the basic part and then step by step climb into the difficult part, right? So once you're done with the basic part, I don't think that there won't be any question that you won't be able to solve up. Okay, so please make sure that you are able to follow what I'm trying to say. Okay, so please make sure that you are only referring to any one textbook and not jumping between multiple textbooks. I hope this answer to the reference textbook is clear. Okay, and also for notes, you can follow these lectures. After the lectures, whatever questions I'm giving you, please try to solve. Okay, so please make sure that whatever I'm giving you, please solve those questions and try to be, first of all, also important thing is that please also make sure that you finish your previous year questions. Sir, I have black book. Yes, black book can be there, white book can be there, right? Red book can also be there. What does this mean? I have black book. Why are you associating color with a book? Anyways, so I hope I was able to clear the concepts of this particular lecture that was going to be on the lines and the planes, right? So in the next class, we're going to discuss about the remaining portion about the finding of the projection of a line onto a plane. So there can be another question that is like something like this, that a question might give like you have a plane and you have a line which is not lying on the plane, something like this, and you have to project this particular line onto this plane, and you have to tell me the equation of this particular plane that is lying on the plane. So let us say this line is L1 and the projected line is going to be LP. So LP is the projection. So this is what we will be learning up in our next class. Okay, so line L1, the projection of this line L1 is given as LP. So this is, we will try to learn this part in our next class. So till then, I hope that this particular part is clear. So with this part, I would conclude the session over here, and thanks a lot for joining, and I hope to see you soon in our next class. So if you're new to this particular platform, please subscribe the channel so that whenever we are, and also hit the bell icon, whenever we are live, you will get a direct notification. All right, thank you.